Hi, in this video, I'm going to talk about vector spaces over R. So let's get started. So a vector space over R is a set first of all, and it has two operation. Okay, and let me just choose. Okay, yeah. So I've written plus and dot. Okay, so what is this plus? This is a function from V cross V to V, and this dot is a function from R cross V to V. Okay, and so I will talk about example later. Let me just state what is this vector space definition. Okay, so for every x y in V, x plus y is equal to y plus x, and for every x y z in V, x plus y. First, you if you add x plus y first, then add z, or if you first add y plus z and then add it to x, the this side and this side should be equal. And now let's go to wait for a second, just wait a minute. Okay, okay, so where were we? Okay, so now I am also saying there exists certain element 0 denoted by 0 such that x plus 0 is equal to x. Okay, and so this happens for each x in V, and now for each element x in V, there exists an element y such that x plus y is equal to 0. This is called additive inverse. Okay, so whatever you add, you get back 0. And also, now this dot comes into picture. This dot. So if you take one and multiply with any element, you should get back uh, this this thing back. Okay, now let's there are certain more axiom. Okay, sixth one is just wait a second. Okay, just the sixth one is for each element a in F, not F, we are in R, right? So in R real numbers, uh, what is this? Okay, for each element a b in R, and each element x in V, a b x is equal to a b x. Okay, so here this is dot. Okay, a b is let me choose this. Okay, a b is multiplication in real numbers. Okay, and now dot with this x, so you will get back a vector. Okay, and this vector is equal to, if you do this thing, b dot x, you will get one vector, and then if you dot with a, you will get one vector again. Okay, so this two should be equal. Okay, and seventh is for each element R, and each pair of elements x y in V, ax plus y is equal to ax plus ay. Okay, and for each pair of elements a b in R, and each element x in V, a plus bx is equal to ax plus bx. Okay. So so what I want to say is this x plus y is this thing. If you take one v uh, element v and another element v here, and you add it, you will get a vector back. Okay, and then you multiply with r. Sorry, multiply with the element from r. You will get back a vector. Okay, this vector should be equal to, when you multiply this thing with this. So here is a dot. Okay, and this is also a dot. Okay, so so okay, and you will get back a vector here, and then you add two vectors. You should get left side and right hand side is equal. And also here also you add two real number. Here is this one denotes addition of real numbers, and then you do this multiplication. Okay, okay, and here this one is dot, and this one is also dot. Okay, we will often omit the dot, and you will get the context that uh, this thing is actually this function. This one. Okay, and to be honest, there is nothing special about R. You can take any field. Okay, and so instead of R, you can talk about, let's just say it is remark. Instead of R, you can talk about vector space over C as well. Okay, or any field F. To know more about fields, you can Google what is a field. Okay, mathematical field. Okay, there's a concept of field. You can Google it, and you will know what is a field. R and C are example of field. Okay, so now let's go to some example. Okay, so let me just illustrate. Okay, let's say we are in. I want to talk about vector space examples. Okay, so the typical example I would give is example one. This one is R2. R2 is a, oh, okay. Why is this happening? R2 is a vector space over R. Okay. So what is R2? R2 is this ordered pair A, B, and A and B both belongs to R. Okay. And how we define the addition? We define the addition like this. A, B, let's say this is one, and let's say this is another one. We add it like this: A plus B, sorry, A plus C and B plus D. Okay. And now see this. We also want a dot product, right? Here you can see. Here you can see we define the addition. Two vectors we are adding coordinate wise. Like A is getting added to C, B is getting added to D. Now we want a dot from R cross V to V. Okay, so this thing, this I'm taking to be CA and CB. So in short, our V is R2. and we are talking about R2, vector space R2 over R. Okay, now check that this thing happens. X plus y is equal to y plus x. Okay, so how will you check that? Let's say x is our AB, and first axiom, y is equal to CD. Okay, so x plus y is equal to AB plus CD. Okay, so this one is A plus C, B plus D. Okay, and now y plus x is equal to CD plus AB, which is C plus A, D plus B. So, but this C and A are real numbers. So C plus A is A plus C, and D plus B is B plus D. Okay, so this is equal to x plus y. So first one is done. Now second one, x plus y plus this thing. You again check this thing also holds. Mhm. This thing also holds. You check it. Okay. Now what will be take as our 0? In this case, this I'm leaving as an exercise for you. You check this one. So the third one is 0. What will we take as our 0? So I am taking 0 as my this one. Okay, so let's see, you take a random vector x a b, you see x plus 0, we should get x for all x. Okay, so a b, and my 0 is this one, 0 0, this element. So we are getting a plus 0 is 0, b plus 0 is b, so we are getting back x again. So third one is also verified. You see, this one, x plus 0 is equal to x. Okay, now we also need to verify x, uh, x and y. For x, we need to find in y such that x plus y is equal to 0. Okay, so in this case, x is equal to a b, my y will be minus a minus b. See, a b plus minus a minus b, this one is equal to 0 and 0. Okay, now fifth one, what is fifth one? This is identity into x is equal to x. So this one also you check. What have we defined as our dot product? This thing. Okay, so how do I highlight this? Okay, my pen is not working. Oh, hi. Now my pen is charged and we can get right back to it. Okay, so we have defined c dot this thing. C dot this is equal to CACB. Okay. So now we want to verify 1 dot x is equal to x. So this is our x, this is our 1. So 1 dot x is equal to, as per our definition, this is 1a, 1b. And now 1 into a is a. This is real numbers. So 1 into b is b, and so we get back x. So fifth is verified. Now we have to verify sixth, seventh, and eighth. Sixth and eighth you can verify on your own. I am leaving that up to you, and we will. I will verify seven. Okay. So next, okay. So I have chosen E here so that we don't get confused. Okay, instead of C or anything else. Okay. So this thing we need to verify. So I am taking x is equal to a comma b and y is equal to c comma d. Okay, and now if you see E dot this thing is equal to E dot A plus, this is by definition A plus C, B plus D. Okay. And now EA plus EC. Okay. And this is because when E gets inside, it will act like it will multiply with both of them. Okay. Because this is our definition of this dot. Okay. So now this will be EA plus EC and EB plus ED. Okay. Now let's compute this side, and this side will be E dot X plus E dot Y is E dot AB, E dot CD, and this will be EA, EB, and this is EC, ED. And now if you add, this will be EA, EC, EB, ED. Okay, so both of them are equal. So this verifies 7, and the rest you can verify. So bye.